Before you multiply two matrices, there's one important thing you will need to consider doing, as that is what we tell if you need to proceed on finding the product of the two matrices, because sometimes the product of two matrices might not exist. So what exactly it is? Consider a matrix A to have a dimension row by column, and another matrix B to have its own dimension as well in row by column. If you are to evaluate AB, that is matrix A multiplied by matrix B, then you have to multiply their dimension as well. So I'm going to have it as row by column. I'm going to put the subscript A to show that it's a dimension for matrix A. And we are multiplying that with matrix B with its own dimension as well to be row by column, but with the subscript B. Now, when the number of column in the first matrix is equals to the number of row in the second matrix, then the two matrices are said to be able to be multiplied. That is, their product will exist. But if C sub A is not equals to R sub B, then the product of the two matrices AB will not exist. And that is what you want to consider doing. Now, one good thing about this is that if the product of the two matrices exist, that is, when C of A is equals to R of B, then you can actually know the dimension of AB before finding or evaluating it, which simply means that after finding the product of the two matrices AB, the dimension of it will definitely be R sub A by C sub B. It will just be this by this. And we are going to show everything with an example. But now you know what you need to first of all do before you multiply two products. Why am I saying this? Because no one is perfect in this world. Your lecturer, your teacher might make mistake while ordering a particular matrix for you in a particular problem or exercise. So before you begin on finding what is not lost, you should know if you have to do it or not, so that you can quickly make a conclusion or reach out to your lecturer or teacher for corrections. Okay, now let's try to put in some practice by doing some examples. So let's begin with number one. Consider the two matrices. Oops. 4, 1, 3, 2. Keep in mind we are going to go over tons of problems so you can master this process. Then multiply by 3, 1, 2, 1. 3, 1, 2, 1. So we are to evaluate these two matrices. Typically, their products, since they are attached together, and there is no particular symbol, maybe an operation symbol like addition or subtraction. So definitely we have to multiply them together. So first, before we begin the product process, we need to be sure if the product of the two matrices will exist. So what is the dimension of the first matrix? Well, if you are struggling with the dimension, I recommend you check out the video on the introduction to matrices, as I disclosed that in that video. I will leave the link in the description, so try and check it out. Or here is just a basic idea of it. We express the dimension in the number of rows first, then followed by the number of columns. This is just multiplication symbol, but it's not read as multiplication, but the word or conjunction by. So keep that in mind. So in the first matrix, how many rows do we have? There's the first row, there's the second row. So we have 2 rows. How many columns? We have 2 columns. While in the second matrix, how many rows? We have 2 rows. How many columns? We have 2 columns. So we have 2 columns. So now you notice that the number of columns of the first matrix is equal. to the number of rows in the second matrix. So definitely the product will exist, and it will be in the dimension of this by this. So the product of the two matrices will also be a 2 by 2 matrix, as this will be the dimension. Hopefully you got that. So now let's put it in practice. To multiply two matrices, you have to multiply all the elements in the first row by all the elements in the first column. You repeat this for the second column. Then you take the second row, multiply it by all the elements in the first column, again in the second column. And that is how it works. I hope you grab that. Or let me try and come again. You multiply all the elements in the first row of the first matrix by all the elements in the first column of the second matrix. Then you repeat it again for all the elements in the second column of the second matrix. Now you proceed to the second row of the first matrix. You multiply all its elements by all the elements in the first column of the second matrix. Then you repeat it again for all the elements in the second column of the second matrix. And boom, you're good to go. So now, let's begin. 4 times 3, that's 12. 1 times 2, that's 2. So we have to add them together. So we have to repeat it again for the second column. 4 times 1, that's 4. 1 times 1, that's 1. That's 1. And close it. Now, proceed to the second row. 3 times 3, that's 9. 2 times 2, that's 4. 3 times 1, that's 3. 2 times 1, that's 2. Just try and do the math. 12 plus 2 is 14. 4 plus 1 is 5. Then 9 plus 4 is 13. 3 plus 2 is 5. This is our final answer. Notice that the dimension of this final answer is also 2 by 2. So definitely we are good to go. And that is the solution to the first problem. Number 2. Consider 3, 2, 1, 4 and 2, 3. So as we have been doing, let's try and be sure if the product will exist. So the first matrix has the dimension 2 by 2. And we are multiplying it with a matrix that has 2 rows but 1 columns. So that's 2 by 1. So it notice that this and this are equal. Then the final answer will be in the dimension of 2 by 1 matrix. So let's confirm that. So you take all the elements in the first row of the first matrix, multiply by all the elements in the first column of the second matrix. So now 3 times 2, we have 6. I'm adding that to 2 times 3, we have 6. So there's no more element here, so we just need to proceed to the second row of the first matrix. So 1 times 2, we have 4, 2. Then 4 times 3, we have 12. So adding this up, we have 12, 14. And that is our final answer. And judging what we are saying, we can clearly say that its dimension is a 2 by 1 matrix. And that is the final answer. Number 3. Consider 2, 3, 1 and 5, 6, 7. So, as we have been doing, let's be sure if the product will exist. The first matrix has just 1 row and 3 columns. So that's 1 by 3 matrix. Then we're multiplying it with a matrix that has 3 rows and 1 columns. So that's 3 by 1 matrix. So notice that these and these are equal. Then the final answer will be a 1 by 1 matrix. Let's confirm that. So you take the element in the first row of the first matrix by all the elements in the first column of the second matrix. So 2 times 1, so that's just going to be 10. 2 times 5, that's going to be 10. Then 3 times 6 is going to be plus 18. And 1 times 7 is going to be plus 7. So let's add this up. That is going to be 10 plus 18, that's 28, plus 7, that's 35. So you can see it's about 1 by 1 matrix, just one column. Perfect. And that is the final answer to that question. Hopefully you are now understanding the basic idea and the beauty behind the product of two matrices. So consider this one. Pause the video and see if this matrix will exist. I won't do it. By the way, it's for you. So let me know, does the product exist? If it does exist, what is the product of the two matrices? Let me know in the comment section below. Example 5. Well, let's try and consider something very bulky this time around. Let's consider 2, 3, 1, then 4, 2, 1, 3, 1, 1, and we're multiplying that with 2, 1, 3. So will the product exist? Let's see. What is the dimension of the first matrix? First row, second row, third row. First column, second column, third column. So that's 3 by 3 matrix. So we are multiplying a 3 by 3 matrix by first row, second row, third row, and that's first column. So that's 3 by 1 matrix, 3 by 1 matrix. This and these are equal, so we are having a 3 by 1 matrix at the end of the day. So let's see how that works. Let's multiply. So the all elements in the first row of the first matrix by all the elements in the first column of the second matrix. 2 times 2, that's 4. We are adding that to 3 times 1, that's 3. Plus 1 times 3, that's 3. So second row now, 4 times 2, that's 8. Plus 2 times 1, that's 2. Plus 1 times 3, that's 3. To the third row, 3 times 2, that's 6. Plus 1 times 1, that's 1. Plus 1 times 3, that's 3. So let's do the math. So 4 plus 3 plus 3, that's 10. 8 plus 2 plus 3, that's 13. And with 13, keep in mind. Adding this up, we have 10 at the end of the day. And this is our final answer. Judging what we are seeing, we have 3 rows and just a single column, which actually corresponds to this dimension. And that is it. By now, it should have been used and be perfect in finding the product of two matrices. And this is the exercise I have for you. Consider the matrix 1, negative 2, minus 1, and 3, 1, minus 2. Then multiply that with the matrix 1, 2, minus 2, 1, then minus 3, and 0. Let me know if the product of the two matrices will exist. Also, what is the product of the two matrices? Let me know in the comment section below. Hopefully you find this content helpful. Feel free to subscribe. Thanks for watching. See you guys in the next video. Bye for now.